Hello and welcome to the third installment of our little mini tutorials on software-defined storage and hyperconverged infrastructure. We've talked for the last couple of segments about hyperconverged, and we sort of glossed over the underlying technology for hyperconverged. Hyperconverged is essentially an Oreo cookie, a sandwich of a server component and a storage component with this special glue layer of software-defined storage in between. And we basically have glossed over what that software-defined storage is. So I figured for about the next 5 minutes we can go over that particular technology. All right. Now, you probably have heard of software-defined storage. I'm not going to belabor the fact that it goes by many different definitions. Instead, I just want to point to the fact that we're beginning to coalesce in our view of software-defined storage around two general ideas. One is the idea of hypervisor dependency or hypervisor agnosticism. Of all the products out there right now that call themselves software-defined storage, some of them only work with a specific hypervisor, and some will work with any hypervisor and provide a common management front end for those hypervisor-based storage components. So basically, my argument is that I try to go for greatest possible flexibility, so I try to look for the ones that are more hypervisor agnostic than the tools that are hypervisor dependent. And then the second thing that you encounter as you listen to various vendors talk about software-defined storage is hardware dependency. You know, are they able to work with the hardware you've got? Do they have some specific requirements for hardware? Are they inflexible? Do you have to buy a kit or a pre-configured node that only works with their particular box? If you have to do that, you might be in a bit of a stranglehold later on, as we'll see. So I try to go with the most flexible software-defined storage solution I can find in terms of the hardware components that it supports. All right, so basically what I'm trying to get to is the fact that it's a two-edged sword, this virtual SAN that we're creating with software-defined storage. If you're buying one that is dedicated to a hypervisor, you've bought VMware and you're going to use their virtual SAN, or you buy Microsoft Clustered Storage Space or Microsoft Hyper-V and you're going to use Clustered Storage Space, which is the Microsoft version. The strength of those solutions is that you're going to get coherent management, one throat to choke. You buy the hypervisor, and inside the management tab for the hypervisor, you're going to see all the storage components as well. You're also going to have very simplified resource and service management. So you're going to be able to allocate the resource to workload very readily using tools that you're already familiar with. And of course, there's great efficiency in terms of using their replication and their mirroring functionality. And there's a lot of availability and fault tolerance if you go with their nodal configurations. By now, you've heard me say several times that oftentimes requires that you deploy a minimum of 3 nodes, which can be quite expensive. That would be one of the problems on the weaknesses side, is the cost of the solution, which is sometimes quite high. You're dependent on a single vendor, so if anything happens with their product, that if it goes in a direction that you're not happy with, you're kind of wedded to their approach in any case. You got the high cost of a minimum 3-node configuration and a lack of options available there, and they aren't necessarily embracing best-of-breed technology, so you're kind of stuck with whatever the vendor is going to endorse and adhere to in their particular approach. And then finally, it may not really fit the reality of your data center. We could talk a little bit more about that later on. So it's a two-edged sword, and you just have to be aware of it. You also have to look at the micro issues. Those are kind of the macro issues. Micro issues are what storage components are actually supported. Are the flash components that I have, the disk components I have, maybe the old array chassis that I have, are those all supported? And the interconnects, are we doing iSCSI? Are we going to do some sort of fiber channel thing? Are we going to do just a direct attach configuration using a serial SCSI interconnect of one sort or another? And then also, does the solution use storage resources efficiently? You know, what's interesting is that everybody says that they embrace flash and they want to use flash for caching, but in one case you have somebody who's doing deduplication deduplication. One of the hypervisor vendors does deduplication, and they write the whole data set that's going to be duplicated to or deduplicated to the flash components, and then they begin to slice and dice it with their algorithm, and they're basically making lots of small block writes to that flash, so they're going to burn it out a little sooner. That's not an efficient use of the flash technology, and you need to be aware at a granular level of how they're actually using the technologies that are integrated. And then also, I'm passionate about management. If I can't get good management, I don't see a technology doing me any favors. I want to be able to monitor the status of everything. I want to have real-time information about what's going on in the infrastructure. And I also need to be concerned, as most of us are, with bottom line, the cost, whether it's in line with my budget or not. When I'm forced to deploy 3 nodes for high availability instead of 2, that begins to confuse management, and they begin to wonder why they're spending that kind of money. Okay, now in the case of Starwind Software, which is one of the leading software-defined storage makers in the world today, they strive not to compete with the hypervisor vendors, but rather to be complementary to them, to give an alternative to using that inline functionality that may not be best of breed, and instead to be able to deliver the same kinds of services but in a better way, make better use of the hardware, keep the costs low, improve the manageability of the solution. And that's what we're going to be hearing a little bit more about in a minute. But finally, I have to say that cluster storage spaces may be well designed to handle the data from the bulk of your Hyper-V environment, in other words, from the virtual machines that are running in Hyper-V. But what about the workload that isn't Hyper-V, that may be in your shop? If you have a mixture of hypervisors, or you have some applications that aren't virtualized at all, can we support that with clustered storage spaces? The answer is really no. It wasn't designed to do that. Supporting different hypervisors with storage and common management is something that you can get from a third-party software-defined storage vendor more often than you can get from a hypervisor vendor who has it in his best interest to really only support his own workload. So at this point, I want to turn this over to Max Kolomeytsev and let him talk about what software-defined storage from Starwind Software is going to bring to the party here. Thanks, Max.
Thanks, John.
Sure.
So it's quite important to understand that your virtualization environment has to support all workloads, and if it's limited to certain workloads, at some point you're going to hit a wall and you need to change the solution which works for your virtualization environment. And with Starwind, you don't need to focus on certain storage like it is with SAS JBots in case of Microsoft storage spaces, or to have a lot of servers like it is in the case of storage spaces direct. The idea is much easier than that. So as I said, no JBots to operate. It can be all DAS, it can be your existing SAN, it can be a dedicated JBot to increase your compute and storage density by having a small 1-unit server and then a JBot directly attached to that server, but just as a storage resource, not a thing which is focused. And supporting all workloads is also quite important. And the peculiar thing about Starwind is that just 2 servers are required to get a highly available setup. So you don't need 2 servers and a SAN, you don't need 2 servers and a JBot, you don't need 4 servers like with storage spaces direct. So we're really able to shrink down, to scale down this configuration with Microsoft and deliver it to those who want to use Hyper-V, who want to benefit from it, but they really don't need that big of a configuration, or they want to get high density, or they have special requirements which require that flexibility that Starwind Virtual SAN provides. And there are much more features in Starwind which make it a really good fit for multiple environments. First of all, we not only mirror the storage between the servers, we also mirror the RAM, which is used as write-back caching. This allows us to make it fault tolerant, and should any of the servers go down, it really acts as RAM on your RAID array controller. So it doesn't drop your data, the data is still available but on the other server. And the other applications which fail over seamlessly, they get a hot cache. They don't need to get that data from the disk one more time. They have all preheated cache. Same happens with the level 2 caching. It's distributed between the servers. It can be used as your level 2 cache as well as your main storage, even if that's one SSD. So you don't really need to put one SSD for flash and one SSD for storage and one SSD for something else. It can be a big array of SSDs providing all these features simultaneously, which is much more useful and flexible because you can easier expand it. Then a log structured file system we provide with our solution simplifies the way you behave with storage. So you don't really need to think, okay, 15K SAS and 1, 2, 3, 4, 5, okay, I'll need 45 spindles of 15K SAS. That's quite expensive. So what we do instead, we make sure that the I/O going to our storage is getting sequentialized. Random I/O is killing the spindles. So we sequentialize it, we turn our throughput into our IOPS for writes by writing everything sequentially. Obviously the reads become really random, so the idea with reads is to use portion of the storage as flash and accelerate reads in flash. And by using SATA spindles in a combination with flash, we get extreme performance from a quite simple configuration. And finally, if you have hardware, you can deploy this solution as a software on top of it. But if you don't need or you don't have hardware at this point, there is an easy way to deploy your virtualization platform. Starwind just came out with a hyperconverged platform which combines all the components together, already glued, already licensed, already configured. What's really exciting is that we now provide a hyperconverged solution for those who don't have any hardware and want to get it really easy and really simple. So we have pre-configured servers which come with all the components together, licensed, glued, pre-installed, pre-configured. So when you get the boxes, you just unpack them, put them in your rack, and you're ready to go. You can start deploying your virtual machines in just under 10 minutes. Thank you for staying with us. I hope it was interesting for you. Have a good day.